good morning, good midday, or good afternoon. Welcome by the fourth webinar where we show you how we combine the NVIDIA platform with our Horus Framework. This is my colleague Rens and I'm Matthijs. This webinar is shown in our Meet session, and therefore we have a few basic rules we would like you to follow. Please mute your mic and pin our frame as the main frame to have the best view. We have this recorded during the Corona measurements, and we are expecting to go in a more lockdown situation, and therefore we recorded it previous to that. We will be present during this video and answer any questions in the chat and have a live Q&A at the end of the session. The agenda is shortly an introduction of Horus and the combination of the NVIDIA and the platform. After that, Rens will follow up with a live demonstration of what we have standing in front of us, and I will follow up with that to show you some use cases where we tell you how we integrated this hardware and software in an actual situation. And as I said before, we will finish with a Q&A. We as Horus like to make the world smarter using existing software or situations and increase their functionality or intelligence by adding sensor functionality. We do this by creating the Horus Framework and combining several sensors into one solution. We call this the Horus Insight. A global view of what will help to understand better what the situation is that we have existing hardware, which can be either an NVIDIA board or another embedded board. We combine it with several sensors, and this is done inside the framework. The framework will then improve existing situations, making new, more intelligent solutions, which has mainly imagery as a center of interest. Some examples will follow later. I'll use the same picture again and show you the different use cases one by one. And now give the word to my colleague Rens to show you what we have stand here in front of us.
Hi, my name is Rens. I'm a software engineer at Horus, and today I'll be demonstrating the two systems you see before you. One is the Jetson Nano, which is streaming a simple panorama stitch. The other one is the Jetson Xavier NX, which is doing a bit more, which I will tell you more about later on. Like I said, I will be starting with the Jetson Nano. It has two image sensors connected to it, and it's stitching them together to produce the following stream. This is the 360 degrees panorama created from two image sensors, and it does that in the following manner. This is the complete pipeline running in the Horus Framework. It looks a bit complicated, so I will talk bit by bit how it works and with what each component does. I will start with the grabbers. The grabbers are one of the most flexible parts of this system. In this case, you see four components, two for each image sensor connected to the board. This can be any camera the board would understand. So in this case, it has the raw image sensors, but these could also be the RTSP cameras. It could also be USB cameras or any other video media producing an image that we can process. Because in this case it's raw image sensors, not much is needed for us to process the data. In case of other sensors or other camera grabbers, we need either the networking for it and then process them for us to be able to process it. And that's why the following step is needed. This is the parsing step. In this simple example, all we do is rearrange the pixels so we can understand how they are formatted. But if we would grab an RTSP camera, for example, these could be decoders, decoding H.264, H.265, JPEGs, whatever it needed. whatever is grabbed from the grabbers. After this, we would go to projection component. This is the component which is most powerful in this pipeline. This is what does all the stitching and how the final image is made. This grabs the two images from the sensors, parses it into the component itself, and then spits out whatever image we want. In this case, the stitch panorama. The power of it is that it's not hard-coded. It has a property to a configuration file, and this file tells it how the sensors behave, how they look, how they work, and what the lenses are, or what the field of view is, and how they be stitched together. So because this is so configurable, we could connect anything to this, then describe how they work, what they are, and how they should be stitched. Besides stitching, it can do a lot more. For example, create a virtual camera. This means that if you have the stitch panorama and you only want a certain cutout from the complete image, you tell it how to do it, what the resolution is, how big it is, where you want to look at, and then control that view through external commands. I will show this later in the NX because this is what it's doing currently. After the projection, we need to encode the data. The projection spits out raw image formats. This is a very high bit stream which cannot be sent over the network. It's just too big. So in this case, we're encoding to H.264, which is a smart encoding to really lower the bandwidth. This can be any encoding. It could be H.264, H.265, JPEG, whatever you want, or whatever the attached client on the other side of the network would like to receive. Besides this, we could also wrap it in a container. So this could be MP4 and PGTS, whatever the client application wants, or however you want to consume or report the data. After this, we have the streaming component. In this case, it's our own networking component because we're streaming to the Horus software running on this laptop. This could also be an RTSP stream, or it could be raw UDP, TCP, or whatever you want. You could also split it up to a recording, to make a recording, so you can look back later or do whatever you want with it as a post-processing step. So like I shown you before, this is the final result that we get from the Jetson. You can see the entire image, and Matthias can walk around the room to show you the live view of it.
As you can see, I'm walking through two sensors which are stitched together round about here. There's a perfect follow-up from one image to the another. This is all done real time. I can throw this and you can see it's sketched instantly. Ooh. I'll leave it there. But what you can see is that it's close to real time and will tell you that, and again, give you a stream which is 360, which has a very nice blend into each other and have a good awareness of a 360 surrounding. An example we can use here for this is we use it on a police dog. They give a harness, shown in the picture, and they have additional eyes and ears. Actually, they have additional eyes, and we can also add some additional ears, so make audio also connect over the network to the trainer in this case. So therefore, we have a use case where they can have surveillance on difficult to reach areas or riskful areas, such as damaged buildings or even counter-terrorist situations. They can send in the dog, do some surrounding checks without having any risk for the trainer to be standing far away and having real-time 360 awareness. With only two small sensors and a very dedicated piece of hardware to do so. Very low power, real-time 360 all over the network, actually.
Yeah. So the other example we have is the Xavier NX. It's a bit more powerful than the Jetson Nano, or it's a lot more powerful, even though it has the same size. It just comes at a difference in price. What we can do, with the difference in power, I can show you next. Here you see a bigger pipeline than the Jetson Nano. It comes because of the additional functionality. But just as before, I will show you each step what it does and show you the differences between the configurations. Here as well, we have the same grabbers as the Jetson Nano, the two sensors attached to the board. Then, just like before, it's being parsed to configure it to a format we understand. And then it goes a bit different. In this case, we have two projection components. This is because the NX at this point is streaming, besides the full panorama, the 360 view, it's also streaming the VCam that I talked about earlier. So this does pretty much the same as on the Nano. It has a configuration file describing how the sensors work, what the lenses are, and how they should be stitched together. Besides that, I also have this one, this projection component. This takes the same configuration as the other one, but adds additional properties to tell it that no, we want a virtual camera inside the view, and we want to be able to look at this point with this field of view, so we can stream just the part you want. So for example, if you want to focus on a certain part in the 360, you can point it at that to stream that to whatever you want. Then, just as before, only now we have two encoders. The one on the bottom encodes to H.265, the one above encodes to H.264, just to show the difference of capabilities we have. Besides the fact that now we have two encoders, because we have additional power, the panorama now is the complete 4K image, while the Jetson only streams 2K at this point. Besides, it also encodes the H.264 lookout as a 1080p stream. So now we have, because of the more power, we can have multiple streams and higher resolution. Or, depending on the grabber, you can have higher frame rate, or even more cameras stitched together in different ways. Then, just as on the Nano, we have the two streamer components. They both stream to this laptop again, so that we're using the Horus streamers. But just as before, this can be RTSP, UDP, TCP. An additional benefit is if you would stream RTSP, you can use our system to create an on-flip server and stream to software like Milestone. So you can directly record or view what you want from a remote system. And as a final step, I've attached an Xbox 360 controller to the Jetson. This gives us the possibility to control the VCam used in the earlier projection component. This component listens to the inputs from the controller, and in that way I can move the crop in any way I want. So it behaves as normally a PTZ camera would. Besides, this is now a static setup with no moving parts, but you can still look around and zoom as you would expect a PTZ camera. So this produces the following image. In this case, I have the 4K complete panorama. You can look around the room again. Besides that, and I also have the lookout stream. So in this case, it's looking at the camera over there. But if I grab the controller, I can move around. Left, right, up, down, zoom in, zoom out, just as you would a PTZ camera. In this case, I'm using an Xbox 360 controller, but if you created an on-flip server, you can use the PTZ commands from Milestone. If you want a controller remotely, you can attach the Xbox, for example, to this laptop, send the commands over the network. This shows how flexible our system is.
One of the use cases we have is tailored. They used with us to make an NVIDIA board with our framework to get a 360 awareness. They're manufacturing robots and have robot arms on which they want to have a PTZ camera to not move the robot, but still have a look around above or around their moving object. What we could do is find a very small PTZ which they can control from elsewhere, from where the operator is standing. Instead, what we made was a 360 solution in which the VCam, as earlier explained, is running. So we have a full awareness and they can send controls similar to Xbox controls, but from their operating perspective, to move virtual in this 360, making them not having any moving parts and all the flexibility to look around while still being able to move their own part of the robot. A good example here is that we started with the Nano, trying to getting the result they required to having this VCam running into a 360. It turned out the resolution required was higher than we were expecting up front. So we needed more power and moved to a more efficient or a stronger embedded board, which is the NX for this example. So without changing any code or minimum code, we can still get the result we wanted. Addition to that is the code we have written earlier. So the end customer, TaylorOp in this example, didn't need to write any code. They just ordered the solution and we assembled it in the pipeline for that. Similar to this, anybody can get access to pipelines like this, run their own concept prototype and develop their own setup as we are doing in this case for our customer. Different project which has also a lot of similarities to what we have shown so far is the police robot. It has different cameras, so the sensors to start with are different. We changed that part of the pipeline. But they want to have a more or less similar result. They would like to have more 360 awareness on their robot. It's used for having better awareness when they are driving. Instead of when they are moving an arm, they have it fixed positioned up front of the robot, able to drive to any area and be able to move easily with the camera sideways without moving the physical robot sideways. So we made a 360 on top, and instead of projecting it to a screen, we projected it into a VR goggle, having the operator attach the goggle and have the controls in their hand, making it able to look around and have the robot fixed in the position when it's clear to move, so there's no interference or any other obstacle in the way. You can continue driving and operating the robot as it should. These are two examples which have a lot of similarity, but are still very specific to their needs. Having this flexible hardware and software solution together, making it easy to have these kind of solutions in very short development time. Having a very adjustable area where we can see during the process that things need to be changed or adapted to the situation. We can easily move either hardware or software to make still the perfect fit for the solution. I think these are two very good use cases to finish up, showing the total possibility of what we are showing today.
Yeah, so that was our demo of today. I've shown you the two systems you see before you. It was quite a complicated story in a short amount of time. So if you have any questions left, please feel free to ask us after the video is over. We are available in the live chat for you, so you can ask anything you want. Thanks for listening and have a nice day.
Goodbye.